Good morning. This is pre-algebra for Friday, March the 20th. Okay, today we're going to talk about positive and negative numbers. And it's very simple. When you were in kindergarten and in first grade, you began to add numbers. Now, nobody told you they were positive numbers. They just said, oh, you have 2 apples in this hand and you have 2 oranges in this hand. How many pieces of fruit do you have? And you said, oh, and I just added them together. Now, the same principles work in positive and negative numbers. It's just a matter of understanding one simple rule. Let's look at our first problem. We have a -2 and a -3. The signs are the same. So all I'm going to do is add my numbers. I'm going to add my -2 plus my -3. Well, 2 plus 3 is 5. And since they're both negative, my answer is negative. Very simple. If both numbers are negative, simply add them together, your answer is negative. Now, if both numbers are positive, this goes back to what you were doing in kindergarten, +4 plus +3. Well, 4 plus 3 is 7. They're both positive, so our answer is positive. This rule simply says if the 2 numbers you are adding are both positive or both negative, the signs are the same. Add your numbers together and keep your sign. Pretty simple. Now, what if the numbers are different? It's still very simple. What if you have -4 plus +3? Well, what's the absolute value of -4? Well, the absolute value, remember we learned that those little slanted lines tell us absolute value. The absolute value of -4 is 4. The absolute value of a +3 is still 3. Now, when the signs are different, we're going to subtract our absolute values. So 4 minus 3 is 1. Now I'm running out of room, so I'm going to write it over here. Is 1. And, erase that so it doesn't look confusing on the video. I'm going to subtract. I'm going to get 1. Now I'm going to look back at my absolute values and say 4 is greater than 3. So I'm going to take the sign of the greater absolute value. So I'm going to take the sign of the 4. My answer is -1. Notice I did not say the sign of the greater number, because if I have -4 and +3, I have more when I have +3. I said take the sign of the greater absolute value, okay? The absolute values is what you're looking at. Let's try it again. If we have -3 plus a +5, the absolute value of -3 is 3. The absolute value of +5 is 5. The signs are different, so that tells me to subtract my absolute values. 5 minus 3 is 2. Now, which is the greater absolute value? Well, the 5 is. So my answer, I take that sign, my answer is positive, a +2. Now, you don't need to write down the absolute values each time. You just need to understand the process. You can surely write them down if you get confused. But let's try one doing it mentally. Say, okay, we're going to do this whole problem mentally. So we have -4 plus +3. Well, the absolute value is 4 and 3, so the difference is 1. Take the sign of the greater one, that's negative. So my answer is -1. So -1, take your next number, -1 plus -5. The signs are the same, so add them together, 6. Keep the sign, the answer is -6. Now say -6 plus a +7. The signs are different, so subtract the numbers 6 and 7. So we have 7 minus 6 is 1. And we have a -6 and a +7. The absolute value of the greater is 7, and it's positive. So my answer is +1. Now, I didn't need to write all of those numbers down. All I have to do is keep track in my mind, thinking them through. Let's look at the next one. If you have -4 plus +3, the signs are different, so the answer is -1. So now we say -1 plus -2. My signs are the same. My answer is -3. -3 plus -6. The signs are the same. My answer is -9. -9 plus +5. My signs are different, so think absolute values. 9 minus 5 is 4, and -9 had the greater value, so we have a -4 is our answer. We have one more here on the bottom. I'm going to give you just a second to walk through it. Answer. Okay, hopefully when you did this, you came up with -10. If you did not, let's walk through it for those that may have missed the problem. We have -4 plus -3. My signs are the same, so I'm simply going to add the numbers, 7, and keep my sign. So -7 plus a +2, the signs are different, so subtract. 7 minus 2 is 5. Take the sign of the larger absolute value, which is negative, so we have -5. -5 plus -5, the signs are the same, so simply add them together for -10. This is how we add negative and positive numbers, or signed numbers. I want you to look in your book, please, to problem set 73. Problem set 73, we're on page 207. The first problem in our problem set today says, the result of 5,400, this was 2.5 times the expected number. What was the expected number? I'm sorry, Mrs. Turner just read the wrong problem to you. Turn to lesson 74. I apologize. Problem set 74. I thought that we just did that one. Problem set 74. Look at number 1. The white cell count was only 980. The patient was in trouble as the count should have been 5.5 times this number. What was the least the white cell count should have been? Now, what was the cell count? 980. What should it have been? Well, 5.5 times that number. So we're going to say to ourselves, what is 5.5 times 980? How do I do that? Well, change your mixed number to an improper fraction. 5 times 2 plus 1 is 11 over 2. 11 over 2 times the number we have, 980. Now again, I put it over 1 because it's a whole number. Can I cancel anything? Well, of course I can. I know that 2 goes into 980 because I know my divisibility rules. And any number that is an even number is divisible by 2. So we divide both sides. We divide the 2 by 2. And then we say 980 divided by 2 is 490. Now, all we need to do is multiply our fractions. And we're going to say 490 times 11 is going to be 5,390. And 1 times 1 is 1. And since our number would be over 1, it's a whole number. So our answer to what should the white blood cell count have been? 5,390. Look at number 2. It says Dr. Hale and his Explorer Scouts traveled 32 miles in 8 hours. First, I want you to write down that ratio. Write down the ratio of how much they traveled. It says, the book says they traveled 32 miles in 8 hours. So your ratio should have been 32 miles per 8 hours. Now, let's reduce that because we can, okay? If I reduce it, I'm simply going to say what can I divide both numbers by? Well, I can divide both numbers by 8. So 8 divided by 8 is 1. So in 1 hour, and 32 divided by 8 is 4. So how fast were they actually traveling? They were traveling 4 miles per hour. Go back to your book now. It says Dr. Hale and the Explorer Scouts traveled 32 miles in 8 hours. The next day, they had to travel 49 miles. So they increased their speed by 3 miles per hour. How long did it take to travel the 49 miles? Well, they were traveling the first day at a rate of 32 miles in 8 hours. We reduced that and found they were traveling 4 miles per hour. The story problem says that they increased their rate by 3 miles per hour. So let's take this rate of 4 miles per 1 hour and let's increase it. Increase means to add, right? So we're going to increase the rate by 3 miles per hour. So how fast are they traveling now? Well, they're traveling 7 miles per hour. They're speed demons here, okay? I assume that they are not using a car. All right, so now they're going 7 miles per hour as they explore. How far did they have to go? Look back at your story problem. They had to go 49 miles. Since they had to travel 49 miles, let's write that over here. We're going to go 49 miles. Okay? And we need to know how long it took them. So we're going to use the ratio of the rate of 7 miles, and I'll write it up this way so it makes a little more sense to some of you. 7 miles in 1 hour, okay? 7 miles in 1 hour. So we're going to take that rate, that's how fast they're going, by how far they're going. Now, when I come down here, my answer needs to be in hours. Since I need it in hours, I'm going to write it as 1 hour per 7 miles. It doesn't matter which way I write the ratio, it equals the same thing. I need to change it so that I can find the answer I need in my particular problem. My miles are going to cancel. My unit is going to cancel. So now I know that my answer is going to be in hours. It's the only unit left. I'm also going to say, 7 and 49, I can cancel those. 7 divided by 7 is 1. 49 divided by 7 is 7. Now I have 7 times 1 hour, which equals 7 hours. And here I have 1 times 1. It's just telling me that it's a whole number. So how long did it take them to travel that amount? It took them 7 hours at the rate that they were traveling. Let's look, let's look at number 3 in your book. The ratio of winners to losers in the throng was 7-2. I want you to write the ratio of winners to losers. Okay? If you wrote 7 winners to 2 losers, you're correct. Now, could you have written this ratio the other direction? You could. I could easily say it either way. What's important about doing a ratio proportion problem is that you keep the same units on the top and the same on the bottom. I happen to put the winners on the top. That means in my proportion, I must put the winners on the top of the other side, okay, and the losers on the bottom. Let's go back to our story problem. It says the ratio of winners to losers in the throng was 7-2. If there were 4,200 losers, how many winners were in the throng? Well, I'm going to go back to my proportion, and I'm going to put the 4,200 losers. On the top or the bottom? On the bottom, because I have to have losers on the bottom on both sides. If I had it on the top, they have to both be on the top. They have to match. Now, I don't know what the winners are, so I'm going to put an X. Now be careful, don't use your labels here. I only put the labels on there to help you make sure you're putting them in the right spot. Use only your numbers and your X. How do I solve a proportion problem? I'm going to cross multiply. I'm going to say 2 times X